You know, when we talk about human population growth, it's so easy to just picture one giant number, right? But that's not really the story at all. The real story, well, it's actually thousands of different stories, all unfolding at once, all over the world, and all at their own pace. Okay, so just look at these two diagrams. On the left, you've got the United States, and on the right, that's Guatemala. They could not look more different, could they? One's like this sturdy column. The other is a super sharp pyramid. And these shapes, they're not just data points on a chart, no way. They're basically prophecies. The US chart, it's telling us to expect slow, steady growth. But Guatemala's? That pyramid is screaming that its population is on track to double in just 30 years. Wow! So this brings up the big question, the one we're going to tackle today. How can two countries be on such completely different paths? I mean, what's going on here? What forces are at play that are shaping their futures so differently? Well, to figure that out, we've actually got to go back in time. See, to understand where we're all going, you have to understand where we've been. And our shared past is, well, it's a wild story. It's defined by thousands and thousands of years of things barely changing at all. And then boom, a sudden world-changing explosion. For most of human history, tens of thousands of years, life was just brutal. Food was hard to come by, predators were a real and constant threat, and diseases were everywhere. And you can see it right here in this graph. That incredibly long flat line, that tells the whole story. All those things kept death rates punishingly high. We're talking so high that until pretty recently, only about half of all children even survived to become adults. Just think about that. But then, everything changed. Civilization started to advance, right? Life got a little bit easier. And then came the Industrial Revolution in the 1800s, and that lit the fuse. All of a sudden, food supplies became more reliable, we could ship goods all over the world, and that long flat line we were just looking at, it started to curve, and curve sharply upwards. And the results were just staggering. We got better nutrition, sanitation improved, modern medicine came along, and death rates just plummeted. But, and this is the key, birth rates stayed high. And that simple imbalance, right? Low death rates plus high birth rates. Well, that's what ignited the rocket launch of exponential growth. Our population numbers just shot straight up into the sky. Now, this incredible growth really worried an English economist named Thomas Malthus. About 200 years ago, he looked at this trend and made a pretty grim prediction. He basically said the only things that could ever stop this runaway train were war, famine, and disease. As far as he could see, our growth was completely unsustainable. But here's the thing, Malthus didn't have the whole picture. Turns out that population explosion didn't just keep going on that same crazy trajectory forever. A new and surprisingly predictable pattern started to emerge all over the world. It's something we now call the democratic transition. And this is a really crucial point. While the total number of people on Earth is still going up, the rate of that growth, how fast we're growing, actually peaked way back in the early 1960s. It's been slowing down ever since. And this was the plot twist Malthus never saw coming. The rocket, as it turns out, was starting to level off. So what explains this global slowdown? Well, it's a really powerful pattern called the demographic transition. You can think of it as a predictable journey that pretty much every country goes through as it develops. It's this dramatic shift from a time of high birth rates and high death rates to a time of low birth rates and low death rates. In fact, we can break this whole thing down into a simple 3-act play. Okay, so Act 1, that's most of human history. Birth rates are high, but death rates are also high, so the population is pretty stable. Then comes Act 2. Advances in medicine and sanitation make death rates plummet, but birth rates, they stay high, and that's when you get the population explosion. Finally, in Act 3, as things like education and living standards rise, birth rates start to fall to match those low death rates, and population growth slows way, way down. This graph right here really brings that 3-act play to life. Look at stage 1. See how the red birth rate line and the blue death rate line are both high and kind of close together? Okay, now watch what happens when stage 2 begins. Notice how the blue line, the death rate, it drops first and drops fast. That massive gap that opens up between the two lines, that is the population explosion. Then finally, in stage 3, you see the red birth rate line start to come down to meet the blue one, and things begin to stabilize. So, the question is, how can we tell where any given country is in this 3-act play? Well, it turns out the folks who study this, demographers, have a really powerful tool that's kind of like a window into a country's past, its present, and even its future. Yeah, the scientific study of all this stuff is called demography. And demographers, they look at a population's characteristics, things like birth rates, death rates, and especially its age structure, to figure out exactly how it's changing over time. Which brings us right back to these charts we started with. They're called population pyramids, or sometimes age structure diagrams. And honestly, they're like a demographic fingerprint for a country. They break down the entire population by age and by gender, giving us this incredible snapshot of that country's unique story. And the real power of these pyramids is that you can literally read the future in their shape. A country like Guatemala is a classic example of stage 2. Just look at that super wide base. That means a huge chunk of the population is under the age of 15. Now, as this massive generation grows up, what are they going to do? They're going to have kids of their own, creating this powerful wave of future growth. It's built right in.
Okay, now let's hop back over to the United States. It's clearly in stage 3. The shape is way more rectangular, almost like a column, right? And what this tells us is that there are roughly equal numbers of people in the pre-reproductive years and the reproductive years. A structure like this one predicts a much slower, more stable rate of growth, at least for the near future.
But there's actually a third shape to look out for, and this one points to a very, very different future. In countries like Japan, the pyramid is top-heavy, kind of like an upside-down pyramid. It's narrower at the bottom than it is in the middle. And what that signals is that there are fewer young people than there are older people. And that kind of structure, well, it points directly towards population decline. Okay, so let's recap. We've seen the historical explosion, we get the demographic transition that slows everything down, and now we even have the tools to read a country's future. So what happens when we zoom out and apply all this to the entire planet? What does our collective future look like? All right, take a look at this. This is the projection for the entire world's population in the year 2050. The green part shows you what the pyramid looked like back in 2002. The blue shows where we're headed. See how it's changing? It's transforming from a pyramid into more of a rectangular column. That's the signal, right there, that the world as a whole is entering stage 3 of the demographic transition. Our collective growth rate is slowing. But, and this is a big but, even with that slowing growth rate, the momentum from the last century's population boom is just immense. So current projections are still telling us that by 2050, the world population is likely to hit 9 billion people. So, if there's one crucial thing to take away from all this, it's this. That dramatic J-shaped curve of exponential growth we saw earlier, it's finally bending. It's transforming into what scientists call a logistic or S-shaped curve. The growth is slowing, and it will eventually stabilize. But we still have several more decades of pretty significant growth ahead of us before that happens.
So, in the end, maybe the most important question isn't just how many people will there be? Maybe the real question is, where is each country in its own unique demographic story? Because the challenges facing a young, rapidly growing nation are completely different from the challenges facing an aging or even shrinking one. Our shared future is going to be shaped by this complex, incredible tapestry of all these different paths. And the only question left is, are we ready for it?